Welcome to the new chapter Acid Bases and Salts. This is an introductory lesson, and in this lesson we'll be looking at the acids and bases. Okay, what are the properties of acids? Acids have sour taste. For example, you might have tasted lemon juice or unripe citrus fruits. These fruits have acids, okay, and acids are sour to taste. They are sour chemicals. They turn blue litmus to red. We'll talk about litmus test later on. Litmus is actually a type of paper, litmus paper, and there are two types, red and blue. So what happens when you dip blue litmus in acids? It turns red, okay? They are corrosive in concentrated form. Corrosive means damaging, and in concentrated forms, very concentrated acids are very dangerous. They are very corrosive. Wherever they drop, they can burn that. For example, they can burn metal, they can burn skins, they can burn fabric. The aqueous solution of all the acids are good conductors, and they conduct electric current, okay? So whenever you pass electric current through an acid solution, it conducts the electricity because acids are electrolytes. What do you mean by corrosive property? As I said, corrosive means dangerous or damaging, okay? Because acids have damaging property, they can burn your skin, they can eat metals. When acids are dropped on the metal surfaces, for example, over here this is metal, and on that some acid was poured and this metal has got corroded, okay? So metals have damaging properties. They can burn skin, they can burn metals, and they can also burn your fabrics or clothes. And that is why whenever concentrated acids are used in the lab, you are asked to wear the lab coat, because acids can be very corrosive. If they come in contact with your skin, they can damage you badly. Let's look at some common acids that we have in the lab, and I expect you all to learn these acids and their formulas by heart. So we have a very common acid which is called HCl. It is hydrochloric acid. CH3COOH, it's called acetic acid, and its common name is vinegar. HBr is hydrobromic acid. CH3CH2COOH is propanoic acid. H2SO4 is sulfuric acid. HNO3 is called nitric acid. HClO is called hypochlorous acid. HI is hydroiodic acid. H3PO4 is phosphoric acid. Out of these three, we have mineral acids, which are hydrochloric acid, sulfuric acid, and nitric acid. So these acids are called mineral acids in layman language. We have classes of acids. We have two types of acids basically. We have inorganic acids, which are strong acids. Mostly inorganic acids are strong in nature and organic acids are weak in nature, okay? So we have two categories: inorganic acids, which are strong acids, and organic acids, which are weak acids. Inorganic acids have inorganic elements. You know what inorganic elements are, other than carbon and hydrogen, okay? Other than carbon, if you have any other element, you have inorganic. That acid is inorganic. And if you have carbon in the formula, like this one, like in acetic acid, we have carbon atoms. Whenever you see carbon as the skeleton, that is carbon as the skeleton of the molecule of the acid. Wherever you see carbon in the formula, that is organic acid, okay? So all organic acids are weak acids, and inorganic acids are not all, but most of them are strong in nature. Let's look at the properties of bases. Bases have bitter taste. So unlike acids which have sour taste, bases have bitter taste. Bitter means kadwa, okay? When you touch any base, it feels slippery, just like soap, because soap is also made of base, okay? So whenever you have slippery feeling, that is a base. For example, soap is slippery to touch, okay? So soap is also a base. Soap is also made of base, so it feels slippery because bases have slippery feeling. They turn red litmus to blue. Unlike acids, acids turn blue litmus to red, but bases turn red litmus to blue. Again, as I said, litmus is a type of a paper. I'll show you in the next slide. They are non-corrosive except concentrated NaOH and KOH. Non-corrosive means bases are not that dangerous, but still NaOH and KOH can be very dangerous if they are concentrated and they fall on your skin. They are poured onto your skin. They can burn your skin as well. Okay, so they are in most of the cases bases are non-corrosive. Their aqueous solutions also conduct electric current just like acids. Bases are also good conductors and they are also electrolytes, and that is why they conduct electric current. We have some common bases that we use in the lab. For example, NaOH, which is the most commonly used base, it's sodium hydroxide. Okay, Na is sodium, OH is hydroxide. So OH always is pronounced as hydroxide. So always remember sodium hydroxide. KOH is potassium hydroxide, just like that. LiOH is lithium hydroxide. MgOH2 is magnesium hydroxide. CaOH2 is calcium hydroxide. NH4OH is ammonium hydroxide. And we have some bases that do not have OH, like CaO, which has oxygen. Okay, so this is calcium oxide, which is a base. Mg magnesium oxide, N2CO3. Now these three are different from each other. MgO, which is oxide, and CO3, which is sodium carbonate. Okay, so all of them are the bases. Litmus paper comparison. As I said, we'll be talking about litmus paper. So this is what litmus paper looks like. This is red litmus paper. Okay, and you can see once it is dipped into the solution, it is turning from red to blue. So whenever a red litmus paper turns into blue, that always means that your solution contains a base. And opposite to that, over here your blue litmus paper is turning to red, and this solution, contrary to this one, is the acid. Okay, so always remember, if red litmus paper turns blue, that is base, and if blue litmus paper turns red, it is acid. Okay, I hope this introductory video was helpful, and we'll be looking at the next topics in the next video. Till then, thank you so much.